Hi, everyone. Marika, before introducing myself, I have to thank Richard for the nice word in the beginning. I have to thank Greg, my big brother Tom, and Sandy for their talk. I'm Ghaith, deep learning engineer. I'm part of integrated MLAI with Thom Ives. My focus is on the healthcare in general. I have 10 years experience on this in different markets. And the most important for today, I'm part of the MKAI community also.
Thank you so much for the lovely introduction. And our next panelist is Manpreet. Would you like to come and introduce yourself?
Yeah, first of all, thank you, Richard and MKI team for inviting us and being a part of this thing. And myself, Manpreet from India, currently working as a data engineer at Pact. I like NLP a lot, and I host meetups on my YouTube channel on Saturdays, and you would find me talking at Integrated MLAI as well on mentoring sessions, and also planning to build a community to network grow. So don't forget to reach out if it's mentioned. I mentioned everything in the chat, and again, thank you, Richard and team, for inviting us.
Thank you so much, Manpreet. And the next panelist who I want to introduce is Ammar.
Yes, hello. Am I audible?
Yes.
Yeah. Hello, everyone. My name is Ammar. I'm a PhD student. I work in AI. I try my best to learn a lot in my days, as everyone is trying to. Thanks, everyone, for having me. Thanks, Richard and co. And thanks, Tom and Greg. Your presentation was great. Cindy, your presentation, I almost like recorded it in my mind. Thank you so much.
Thank you, Amar. So I would also like to invite our speakers for tonight, that is Tom, Greg, and Cindy, to join in our panel discussion. So to start off, I would like to ask the first question, which is it very popular to speak about methodologies in ML production? Are there any methodologies followed by researchers to find efficient and effective modeling methods or algorithms?
If it's okay, I'll lead off on this one. And I'm very happy to have Greg and Cindy either disagree with me or add to me. It's fine either way. I would say methodologies for machine learning engineering, actually implementing machine learning, or let's even just say data storytelling and dashboards, are becoming more popular lately, and it's a good thing. If you look back to sorry for my background noise, I have a lively family. If you look back over the history of engineering and how engineers adopt new physical principles to implement in the world for human benefit, things like, well, how do mechanical engineers make sure they're incorporating Newton's laws of motions properly? They use free body diagrams. How do electrical engineers do circuit analysis for analog circuits? They do voltage loops and current analysis, current loops and current nodes. And these are well-established methodologies, but I want to point out something. Any great masters in any domain, they mastered the basics first. How did they do that? Through learning methods, through application methodologies. Now, thank God, we're beginning to see an emphasis on this in data science and machine learning. But the question on, are there a set of methodologies for research? This is kind of a holy grail thought in my mind. And if any of you have ever heard me give my talk, Integrating Brilliance, it is aimed at doing that for research and really everything in life. It's a Michael Faraday mindset. He's a truly amazing man, basically encouraged us to be humble enough to learn from everyone and everything and become, in essence, an observer of the whole universe. With that, I'd like to hear what Greg and Cindy might add.
I can add something real quick. When when I think about researcher and great illustration, Tom, And I know Cindy will bring us home. But when I think about a researcher builds on existing. They work in chaos somehow, and they find opportunity in chaos. Existing technologies build on top of that and make new discovery. So for this, necessarily, there might not be a clear methodology. Maybe some part of their work might be based on methodology, like hypothesis checking and things like that. But overall, making these new discoveries is kind of chaotic, and trying and iterating different things. And for that, I'm not sure I know of any headline methodology that they use in the research space for ML. Cindy?
Just a quick build. I think it's a different question a little bit. I would say don't worry about the research and methodologies, because you're not going to find an integrated perfect recipe. I'm with you, Greg, is that there is so much literature and so many research papers, it can be, overwhelming at times. Just step back and ensure you understand the problem in the use case and get narrow there, and then step back and look at the research that could be applied. The reason I'm saying that is I have another venture that I've started with a partner, a chap you may have heard of called Roger Love, who's one of the top voice experts in the world. And we're building out a company focused around emotion and emotional intelligence detection. And, with that literature, that took us to the research in the effective computing domain, right? Because when you're dealing with voice, you're dealing with audio signals, and you're dealing with AI approaches that could overlay the audio. So then it's dug, and we found 5 research scientists that are specialists, and then they bring their methods, and they then bring their research papers. So I remember when I was a partner at Accenture, and this is an important point. Accenture spends millions and millions in knowledge management and documenting. But you know where the best assets are knowing in that discipline, that problem, who the top researchers are. Because the top researcher names, they know where the best sources are. So that's, I think, how you can approach life is, what's the problem? Okay, who's the top researcher? You can, thank God we've got, this group here, you could ask. You get 3 professors, you go check with them, and you know what, they already have their arms, because they'll have their research labs, and then they'll talk about the tools, and then they'll say, we use this software, maybe it was OpenSmile to help, do some early detection, or we found this at University of Penn because they had a good emotional data set that you could train, so that's why I think it's the wrong question. That's how I would come at this. Turn it upside down.
Yes, thank you for your thoughts on that. Would you like to add on to that, Amar?
Yeah, sure. I'm not gonna answer the question. I'm gonna top on over the question. I'm gonna tell you that I'm struggling with this question right now. I'm struggling to find a decent methodology to follow while doing while modeling my algorithms and models. I don't think there is a decent methodology yet. But yeah, it is a big struggle while doing research, and the thing is, when you wanna do a paper, when you have something novel you wanna produce to the world, you need to see what's the state of the art. So in order to see the state of the art, you need to have something like a baseline, which is approved by everyone, like a methodology to follow. Like we do test our model on a 60/60 data set. So that would be the state of the art. It's not there yet. There's nothing modelized. There's nothing that everyone agrees on and test on it. Like, for example, we have ImageNet. When I say I have a neural network that is performing well, it means like I have neural network that is performing well on ImageNet, but this isn't there in the research. There's nothing such as like a standardized thing. So while I don't think there's a methodology, I would love to see one.
Now that seemed to be an important answer to a bit of a different question in my mind, Ammar, which is, how do we measure the performance of these advanced models against one another? And what I've seen the community be really good about, at least in the transformer realm, is create these leaderboards. It seems like as we want to compare these advanced algorithms, these advanced math machines, metrics arise. And I would say it's a worthy research project in itself to create those advanced metrics, leaderboards, and things like that, so we can compare the performance of the myriad of advanced math machines that are coming out in different realms. But I would encourage everyone, including Ammar, my good PhD candidate friend, to think about it this way. There are some amazing intellects, both from history and present day. What did they do? What are they doing? I love to use Richard Sutton as an example. He came from psychology and he developed reinforced learning. Oh my, look at OpenAI, the biggest collaboration of intellects in the history of the world focused on AI. You just start capturing, well, what did these successful AI researchers, math machine developer researchers do? Just start cataloging what are the commonalities? Because in any great art, like design methodology, let's say, that's how we come up with design methodology. We look at what successful designers do. We need to start cataloging what do successful modern day advanced researchers, especially in AI, what do they do and what's common about it?
Let me ask you one question over that. Do you think that we will ever find the best algorithm? Or it will always be case specific, like for this application, this is the best, and for this application, this is the best. So if not, if your answer is no, we won't find the best algorithm, why would we go into that? Why it doesn't even matter to go into that research of finding the best?
I think it's a quest to find the most appropriate math machine, or an adequately appropriate math machine for your current needs. The greatest relief to me when I realized I was not going to be able to get GPT-3 in my hands is Dennis Rothman teaching me through his book, hey, I can give you a model 1,000th the number of parameters that'll spank GPT-3's butt because you trained it on specific data to your needs. Thank you, Dennis. That's all I was looking for. Please maintain the democratization of AI knowledge. I hope that that's just one illustration too.
Ammar, I wanted to also put the focus on why are we even talking about MLs? Like when we talk about business needs, to me, it's about understanding where you are in the current processes and why you want to jump into some sort of automation. The current state most of the time of business would be like poor scalability, human interventions where you have too many errors. And these errors might cost, for example, the business some sort of risk or some sort of lost opportunity. Now, if you have clear ways to capture that with the business, what the impact of that automated solution is, therefore, that's good justification for you to jump into an ML model. So in this case, a human error, for example, happens 5% of the time, and this is the risk that is associated with that, or this is a lost opportunity in terms of sales, etc. Then when you bring in the automated solution, you can reduce that risk down to 2%. And that's good enough sometimes for the business to say, we want that automated solution because you've reduced human errors, you can scale, help the company scale as well. And now you have a good case for jumping into an ML model versus a, say, manual process.
Well, I very quickly want to defend Ammar's question. And your answer was excellent, Greg, to someone in business. But I feel protective of Ammar because he's going through a PhD program. And so right now he's very model centric in his learning. Whereas when we get into business, we tend to be more data centric. But is that accurate, Ammar?
Yes, it is actually, but I know the problem with being model centric, but while doing a PhD, this is what you do. You need to go within the problem, you know. You need to develop something, because no one will ever sit and like stack layers over each others and come up with the new best layer, with the new best architecture, except for researchers. You know, like, and that's what we do. And even if it isn't the best method to follow, it is our job, you know.
Also, like, I think in research work, it's more like what new we can invent, but in business work, what things we can serve to the our customers, what do they want, and is our business model giving that or not?
Yeah, thank you so much for adding on, Manpreet.
Nairika, sorry, I just want to add one thing. This question, I want to ask it to Tom and Greg. When we are talking about the business needs or the business, let's say, the business case that we are discussing and the data driven, sometimes the problem it's discovered by the data. It's not discovered by the business. So in fact, if I go to your metrics, it's shown that we have independent events that the business needs, and then the data what it's giving us, and we are trying to multiply it. It's independent events, but the reality is not independent events. It's related to each other. And this case, what I want to highlight here. Sometimes you can use your model or your AI to discover what problem you have. So it will bring more value to the work. Now, the question itself, it gives me just an idea. The question itself, even if the research, maybe there is no a clear methodology that we are able to discover, then it will ensure us that, okay, we'll find a great finding at the end for the research. Maybe there is not such a thing, but this is something that we can follow by, let's say, discovering what's happened on the other side. Let's say the methodologies, what we name it right now, machine learning methodologies or machine learning pipeline. It's kind of cloning or conceptualizing from the software development lifecycle. So this kind of methodology can be used always. It's not clear methodology, but it's bringing great results. This is what I want to add.
Yeah, I think that's an excellent point. And I'd like to add something to that thinking that you've probably already thought of, Ghaith. When we start thinking of a machine learning development lifecycle, there's a new customer at play. It's the data. If we're going to listen to that customer, we have to learn to speak its language and know how to work with it and explore it and add to it appropriately. It's like its own, it's like a pseudo market, and we have to listen to it to know how to win with it.
Yeah, thank you so much for.
Yeah, I like to add something more. There is a lot of talk regarding the model architecture and how we can standardize but while working a lot on machine learning with business data and all medical data as well, I like to add there is a huge challenges regarding the pre-processing of the data, how we scale the data, and there are a lot of parameters which are actually not scalable, and there we need to invent some kind of methodology. That's why the different kind of like loss function, even the neural network may not be appropriate certain times. We need to use certain other kind of machine learning model or statistical model that need to feed that kind of data. So pre-processing and not rely on a certain architecture, that's the main goal for any kind of business data or medical data. Thank you, everyone.
Thank you so much for adding on to that, Mr. Chakraborty. And we have a question from the audience. Fiona asks, where is the best place to start learning more about AI from the position of an upcoming developer? So I would like the panelists.
Could you repeat it?
Yes. Where is the best place to start learning more about AI from the position of an upcoming developer?
I'll just throw a few thoughts. I think what's key is if I guess, where you are in your journey as a developer. So I don't have the context to be as precise, but if you have already finished your degree, I guess the question is what skills do you have there? And then I think we can probably all answer the question more specifically, because I don't know if you've already learned a language. I don't know if you're skilled in Java. I don't know if you're skilled in C#. I don't know if you're skilled in Python. I don't know if you're skilled in R. So I think that would be helpful for me. But Thom, you may have more precision there. But I
want to draw from. I just want to draw from the great philosopher of the last century, Julie Andrews, in The Sound of Music. We should start at the beginning. It's a very good place to start. I think I already answered this question earlier. Master the basics. You won't achieve mastery in the advanced stuff if you don't master the basics and really understand them well. And in fact, most of the time, you will find that the basics will serve your needs. And it's kind of rare. And if you are a researcher and you're trying to learn to push the boundaries like Ammar, then you still need to know those basics very well to have a clue about where to push. But Cindy brought up a great point, and I'll be finished soon. I would start with Python or R. I have a preference for Python, but I'm not anti-R. Get really good at just doing that, and then start doing basics and dive deep every once in a while. Ammar, please, sorry.
I just wanted to add that I never thought that I would never take something positive out of Billy Andrews, and you would never actually like believe that you need to know the basics until it solves one problem for you, because it's never gonna be obvious. And like I always used to like not be humble versus my problems, and at the end when I got back to the basics and like the problem was like rocking stone in my face, it solved my problem.
One of my many dear family members, an adopted sister, is focusing strongly on learning SQL right now. I am immensely proud of her for doing that. That's exactly where she should be focusing. And then, you know, I'm going to be pestering her. Okay, now that you mastered SQL, can you operate it from within Python? Because that will make you fly, you know. But again, when you ask me, well, what do you spend 80% of your day doing? Pulling from SQL and creating AI memory for expert systems. I do that a lot the last couple of years. It's just been a godsend, but it's the basics over and over.
Also, like adding to it depends from person to person. Like I being a person might learn using projects. A second person might like doing courses and learning through projects. And my top 5 favorite courses would be according to my preference, and your top 5 preference course would be different. So it's like talk to people, what do they think, and list it down, search, and then you can find out and study. That's what I think, because it's everyone's preference, because some might like NG course, some might not like. It's up to people's preference and thoughts. So just adding to it.
Thank you, Manpreet and Thom. So our next question is from Elijah. He asks, how easy is it to pivot your career from accounting and finance into AI?
Oh, I can take that one. It's really easy. There is not. First of all, PwC has done a lot of research on where in large enterprises should the advanced analytics function report into. So many CFOs are lobbying to have the AI and advanced analytics functions report into them versus the CIO. So there's a little bit of a battle going on in the broader landscape. I think the fact that you have an accounting background, you know the importance of return on investment, and you know how to articulate that language. So I think here's an opportunity for you to integrate into the AI teams and being the value realization architect. And that's a very important role. And I believe we're going to see a lot more focus there. in the value realization, the ability to articulate, the ability to help communicate that back to the business. I don't think you'd necessarily need to learn how to program in Python. I think that if you've got a certification, whether it's a CA or a CFA or whatever the degree is, and the ability to analyze the results and help guide them. I always stress at the beginning of these AI programs is get the value realization construct done at the beginning. What is are you trying to predict customer churn? What's the cost of a churn? Get the economics right. So I think you can have a great future on the economic return of these initiatives. Don't think it's hard. Just make sure you're in a company that you can plant onto a project, and make sure your CFO has got some leadership in this area. If not, see if you can move to the IT function if they have it, because the IT function definitely does know that they have to prove their value. So yeah, lots of opportunity for you, cowboy or cowgirl, just go.
Thank you so much, Cindy. And that's such an encouraging talk. So I would like to ask the next question from Amin. He says, how do you go about searching for volunteer opportunities with companies? Related to AI. So how can we start?
Greg would answer this best.
Over to you, Greg.
Could you answer could you ask the question again? There's a piece I didn't catch.
How do you go about searching for volunteer opportunities with companies? So how do you volunteer? Yes.
I would say search, right? I think Google could be your best friend, right? So that's the easiest answer I can give you here, because if it's a volunteering work, there are a lot of platforms out there that are advertising. I'll give you a quick example. Starting tomorrow, I'm part of this global hackathon happening, and Oracle is one of the big sponsors. Now, as part of this hackathon, they are looking at new creative ideas that they're even exploring purchasing the IP and paying you, or even hiring you because you have so much talent. So get involved, like search for groups that are existing out there that are kind of gathering communities to bring new innovations, build ideas, build tech in a very short time period, because those are the things that will get the attention of these companies. And you go from volunteering to getting hired very quickly, or purchasing your new technology. So I'd say go out there and search and let Google be your best friend.
Thank you so much, Greg. So our next question is from Muskan. They ask, what is the scope of machine learning when deep learning has penetrated so much into the market?
I would like to very politely and very strongly challenge, how has deep learning penetrated so deep into the market? I don't think it, yes, in some specialized applications, but when you look at the workhorse, when you look at what's used most of the time, it's probably stuff like linear and logistic regression.
Good morning, Gustavo. How are you?
Good morning. I'm good. Good afternoon from the UK.
There we go. Found the mute button.
there we go. They found it. But I'm open to being wrong on that. By the way, I'm a fan of transformers, reinforced learning, neural networks, deep learning, convolutional neural networks, all of these things. But have I used them on the job? Have I ever needed to? No, I've used a lot of AI, a modicum of machine learning, and a really large amounts of data conditioning and visualization, studying the data. Now, I study those other things because I think they're beautiful and I want to know how to finally applying to some engineering problems someday. But I would politely contend that, yeah, those fancier, more advanced techniques aren't necessarily used a lot in the wild. They are, just not a lot.
I
Thank
guess
you.
it's also dependent on companies. So a very data-centric company like Google, Microsoft, or Amazon would definitely use deep learning techniques. But healthcare or like a publishing company or some other which their priority is not data, but they do still have data, focus on creating something, but we simply sometimes use pandas and numpy and just simple calculations, and our task is done. We don't even need to train models at times. So yeah, I totally agree with you on that.
I just want to make this community aware that I own the copyright on what Manpreet said. And she answered the question that we were talking about earlier. Y'all should scroll up. She gave a very great answer to the last question too in the comments. But yeah, what Manpreet said.
Yes, thank you for adding that. And it's just amazing about the copyright and everything. And I would like the audience to go scroll up a little and check out the conversation that Manpreet posted. So our next question is from Tara. It is there one single source of truth for machine learning algorithms to use when modeling?
By the way, I like this question, but I need more clarification about it. So Tara, if you are able to give us more explanation about it, I will be thanked.
Yes, feel free to unmute yourself and ask your question.
Hi, yeah, I'm just beginning my PhD research at the minute, and I'm really struggling to kind of understand the different machine learning algorithms that there are out there to use whenever modeling, to try and come up with like a framework.
This is a great question. Basically, you're saying you have a machine learning problem set before you, and now you have to find out what math machine is going to serve you best in your efforts. There's clever ways, and Tara, make sure you connect with me and DM me on LinkedIn. We're actually going through a fun problem like this, a small subgroup of us within our integrated machine learning and AI family, where we're just for fun working through the Titanic data set, but we're applying principles that Ghaith and I are covering in our class about how you can automatically look through several different models and find the best one for your given problem. But it's as simple as instantiating a class in Python and having those classes, those different model types in a list, and running through them on your particular data set that you've conditioned to load into each of those models. Now, what I'm trying to tell you, Tara, and I will tell you this over and over, doing data science is simple. It's just not easy. There's so much you have to remember to do in the whole process, and to learn each individual thing can be a challenge, but once you've learned it, you'll often ask yourself, why did I make that so hard? But once you have several of those things under your belt, you realize, oh, I know what I'm doing, but it's just not easy. There's so much to keep track of when you do it.
Yeah, just a quick build, Tara. First of all, congratulations on pursuing your studies. I think you could be quite clever. And here's a business angle. It's going to take you a while to work on your PhD. So you could basically phone Microsoft or Amazon. You got to pick one though, or H2O. Each of these companies has software that you can take your data sample and you can press buttons and it will show all the comparisons and give you the visualizations. And say you want to be able to work in their lab, and this way that you become visible for future recruiting. So that's what I would do. I would think about, getting visible in the crowd early, and they will give you access to the tools. And it's likely a university you have will already have a relationship. So make sure you've got the toolkits, and then just press the buttons. I see that in our team. I see them apply 7 different algorithms on the same data set and look at a set of visualizations, and they, blah. So, make this easy for you.
Thank you so much. We are running short of time, and then there are so many questions that I still need to cover. So one last question for today's panel would be, what is your opinion concerning Tesla electric cars autopilot mode? Despite having some accidents, do you think we need a different approach or more data to improve the performance?
By the way, if we are thinking about this, I think I'm not working for Tesla, I'm not working for Amazon, but for autonomous driving, they are using both. That means there is new modeling, a new method, a new training and learning method are applied just to learn on the edge, and also they are using more data. But that the most critical here, it's more not more data, because here we need instant and immediate decision about it. So it's not about the more data, it's about the how much the data is covering the space of our search space, let's say. So not about more data, it's about a new learning and training method, most probably. But still the data is, the variety of data, it's important.
Yes, I hope that answers your question. And this comes to an end of our panel discussion. There are many questions which can be answered from the chat, just that we have 2 minutes. Thank you, panelists, for having such a great discussion. And I would like to hand over to Richard. Thank you so much, everyone.